They claim the James Webb Space Telescope spotted a large object about 10 light years away moving toward Earth.
The latest observations from the James Webb Space Telescope JWST of 3Y Atlas are nothing short of sensational. On August 6, 2025, JWST's near-infrared spectrograph NIRSPEC locked onto this mysterious interstellar object, capturing data that have upended many assumptions about what these wanderers might look like. What was uncovered is a body whose chemical composition, size estimates, speed, and origin story all raise deeper and more troubling questions than ever before. Before we start, smash the like and subscribe buttons for more updates. Right from its discovery on July 1, 2025, 3I Atlas exhibited strange behavior. Detected by the Atlas Survey Telescope in Chile, this object was seen moving at staggering velocity, roughly 130,000 miles per hour, 210,000 kmh, on a hyperbolic trajectory that clearly marks it as interstellar in origin. Initially, it looked like another interstellar visitor in the mold of 2I/Borisov or Y Oumuamua, but the data from Webb now show that 3I Atlas is far more unusual. Among the most striking findings is just how rich the object's coma is in carbon dioxide, while water vapor is scarce. The ratio appears radically unlike the comets from our solar system. In short, this thing is behaving like nothing we expected. When JWST turned its gaze to 3I Atlas, the spectral data revealed dominant CO2 signatures, small amounts of water ice and vapor, traces of carbon monoxide and carbonyl sulfide, and a lack of iron vapor despite some nickel emission detected elsewhere. For comets formed in our solar neighborhood, water is typically abundant. The fact that here water is suppressed suggests a very different formation environment or resurfacing history. What this means is that we may be looking not just at a comet from another system, but at a relic from an entirely foreign environment whose physical and chemical processes diverge strongly from what we know. Another equally threatening implication flows from size and trajectory. Estimates based on imaging from the Hubble Space Telescope place the upper limit of the nucleus diameter at about 3.5 miles, 5.6 kilometers, though earlier speculative claims argued for tens of kilometers in size. That's already significant, but when you combine this with the interstellar speed and hyperbolic orbit, you get an object that essentially entered our solar system unbound, hurtled through at a velocity and trajectory beyond normal cometary expectations, and yet carries an icy, dirty body whose composition is off the charts exotic. The standard formation and ejection models for interstellar comets simply struggle to account for the specifics here. The age of 3I Atlas may be another bombshell. Dynamical modeling suggests it might have originated from the thick disk of the Milky Way, or some ancient stellar neighborhood, placing its birth perhaps 7 to 14 billion years ago, older than our Sun by a comfortable margin. That possibility alone is astonishing. We are looking at an interstellar object that may predate the entire solar system, and for it to drift across the galaxy, be ejected from its home system, traverse eons in the void, and now plunge through our inner solar system visible to our most powerful telescopes. That is a narrative that forces us to reconsider our assumptions about how the galaxy seeds and populates itself with minor bodies. What makes all this worse than expected is that 3I Atlas doesn't just challenge our comet taxonomy, it threatens to crack open the entire frame of planetary formation and interstellar dynamics we rely on. For example, the high CO2 content suggests a formation region far from a star, beyond a frost line for CO2 ices, or possibly a zone swept clean of water ice by radiation or repeated cosmic encounters. The lack of iron in the vapor phase also suggests that the body's surface or interior has been processed differently than typical solar system comets. Some speculative arguments even suggest unusual metal or alloy signatures, though those remain highly contested. The very fact that those theories are being floated signals how deeply this object is unsettling established models. Another dimension is the tail and coma behavior. Whereas many comets show prominent dusty tails and gas emissions in predictable proportions, 3I Atlas's tail is faint, its dust cloud more diffuse, and its activity appears driven differently. Observations show that dust is being released, but the patterns and proportions are anomalous. That suggests either the nucleus has a very unusual structure, perhaps crusted over, perhaps heavily processed by cosmic rays over millennia, or that the material is not typical comet ice/rock aggregate. If so, what are we looking at? Something more exotic than a mere comet. The implications are profound. If 3I Atlas is truly representative of objects ejected from distant planetary systems, then the diversity of minor bodies in the galaxy is far greater than we ever suspected. The formation pathways, chemical, thermal, dynamical, that give rise to these ejected objects may produce bodies with radically different volatile inventories, crystal states, isotopic signatures, and mechanical structures. This forces a rethink into how we interpret the population of known comets and asteroids. What we have in the solar system might just be a narrow sample of a far broader cosmic menagerie. Moreover, because 3I Atlas is heading out again after passing perihelion on October 29, 2025, at about 1.4 AU from the Sun, our window for detailed observation is limited. That means missing out on full characterization isn't just a missed opportunity. It could mean that our data will remain scant, incomplete, and unable to resolve key questions before the object fades beyond reach. The pressure on telescopes and missions is intense. We're already seeing plans to coordinate with other spacecraft, though practical limitations abound to intercept or pierce the comet's tail or ion plume. If such encounters or observations succeed, they could provide direct measurements of the dust, ions, and metals being released, but time is of the essence. Another disturbing implication is how this object reveals our routine assumptions about solar system visitor objects might fail. The fact that an object from another system can arrive, survive passage through the interstellar medium perhaps for billions of years, then traverse the solar system unscathed and yield surprising chemistry, suggests that previously held boundaries, how we classify objects, how we interpret their signatures, may be too narrow. It raises the prospect that some objects we thought were normal comets might in fact be exotic interstellar interlopers, or that major evolutionary processing happens in ways we have not accounted for. One cannot escape the existential load. By studying 3I Atlas's composition, we might be looking across the boundary of one star system into another, capturing a tiny fragment of alien planetary system history. The high CO2 content may indicate a cold, distant origin, perhaps a system with different elemental abundances and volatile budgets. The possible great age hints at an object formed in a low metallicity environment, older than the Sun's birthplace, perhaps from an ancient star system now gone or long since disrupted. These facts enlarge the scale of what planetary science must accommodate. They also raise practical questions. What if future interstellar visitors differ even more radically? What if interstellar bodies can carry complex organic compounds or even materials processed by non-natural means, a provocative minority view, and thereby require new detection and categorization frameworks? Granted, natural explanations remain dominant and the safest bet. 3I Atlas behaves largely like a comet, outgassing, forming a coma, trailing a tail, moving on a hyperbolic path. But the level of deviation from typical is extreme enough to force reevaluation. Models of cometary formation often assume water ice dominance, typical dust-gas ratios, standard metal releases, and yet here we see a body where CO2 dominates. Iron is apparently missing in vapor phase, and the dust tail is subdued. That suggests one of two things. Either this object is truly atypical, perhaps from a much different region of galactic history, or our typical model of comets is too biased by solar system examples. Either way, the consequence is the same. The narrative of how small bodies form and evolve across the galaxy is incomplete. Further complicating the picture is the fact that trajectories like 3I Atlas's require significant ejection energy from its parent system, survival of the interstellar journey intact, and minimal alteration until encountering the Sun. That means the parent system must have been able to fling a sizable body into the galaxy. The interstellar medium must not have destroyed it, and the object must have retained volatiles, structure, and internal composition for perhaps billions of years. That sets strong constraints on models of interstellar object flux, on survival lifetimes of such bodies, and on the frequency with which we might detect them passing through our system. If we are seeing one so soon, and one so unusual, what does that say about how many are out there and how many more weird ones we might miss? In practical terms, the data from JWST provide a rare snapshot of extrasolar minor body chemistry. They allow comparisons between the building blocks of a planetary system outside our own and the bodies formed here. The findings from 3I Atlas may force revisions in our understanding of volatile distribution CO2 versus H2O dominance. Surface processing lack of iron vapor appears curious, and ejection and exposure history old age, high velocity. Each of these dimensions intersects with questions about how planetary systems evolve, how they seed their zones with solids, how those solids then migrate or get ejected, and how long they remain intact in interstellar space. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on the new James Webb data about 3I Atlas? We want to hear from you. Thank you for watching, and see you next time.